Hello and welcome to the SystemVerilog for verification short videos. This is the second part of class and OOPS. Today we will go through the two most important features of OOPS. They are inheritance and polymorphism. I have tried slightly different methodology to learn this stuff. First, we'll look at the statement of the concept. Then we will go through the memory allocation of it. I think that once we know at what memory things are stored, then it will be really easy to fetch how the concepts will work. And lastly, I'll show you that whatever we are doing, like overriding members or polymorphism, then what is the actual application? Because until and unless we know the actual application of usage, we are not able to understand why we are doing that stuff. So just concentrate on this lecture and you will be able to work with inheritance and polymorphism very easily. Let's start. Our first topic is object assignment, shallow copy and deep copy. So there are three kind of copy we can say here. What will target in everyone is how many times new is called. So let's start with the packet class. Suppose I have one packet in which I have integer I, then some other p, that is another packet. Its instance is pi and class packet. In some module, I have taken its instance packet p1 and I have done p1 equal to new and module a. So here a new is called because the new is called, a memory is created. So I can say that I'm having one memory of packet p1 here. The first thing is assignment. Now, whatever I have written this code, assume it's replacing this place. So here I am having packet p2 and then I have done p2 equal to p1. Now here I have assigned p1 to the p2, but is there a new called? No. There is only one new in this whole code. So there is only one memory assigned and my p1 and p2 both are targeting to the same memory. So what I can say that suppose this is my p1's memory. Here I am having a variable I stored as well as this pi stored. And now what my p2 will be assigned to? P2 will be assigned to the same memory location. Both are pointing to the same locations. Now suppose I am changing p2 dot I. Will it affect p1? Yes, because there is only one memory allocated. So this was assignment. Next is shallow copy. The syntax is like, suppose at this place I have written packet p2, that's the instance, and then p2 equal to new p1. So what I'm doing here is I'm taking another new. New is called one for P1, here is another for P2. So I'm damn sure that new memory is created and P1 is being copied to the P2. But why this is called shallow copy? The reason is that here I can say that objects are not copied from P1 to P2, only their handles are copied. We'll understand what this statement means. So suppose this is my P1 again. It's having two members. One is I and second is some object Pi of class other P. That's other packet. Now what my P2 will be? My P2 will be having one another memory which is having variable I, but the objects are not copied. So this P underscore I is not copied, but both are sharing the object memory. Now what if I want to do complete copy, that is the deep copy. So now what I will do is I'll take instance packet p2, that code is actually written here. Then I'll do p2 equal to new, because here new is done once for p1 and another for p2. I'm having two different memories. Then I will call some copy function which I'll only make, that p2 dot copy p1. After I'm done this, see, this is my p1 and this is my P2, which is having completely different memory even for the object. We'll look at one example to fully understand this concept. So in this shallow copy.sv, let's start with the example. We'll look at all three assignment, shallow copy and deep copy example. I'm taking one class, say eyes. It's end class. Here I'm taking one integer, number of eyes. Let's take one another class. It's some living creature class. And class inside I'm taking one new integer, that is legs, and I'm assigning some initial value to 4. Now I'm taking the instance of this class eyes e equal to new. I'm creating it here. Now finally taking one module, say earth, and module inside that I'm taking instance of having creature class, say animal and human. All right, now I'm taking one procedure, that's initial, begin, end. First of all, I'm making animal equal to new, so I have created one object. New is called once here. Now I want to check this assignment. So what I will do? I will do human equal to animal here. Now let's try to change the variables of human. So human dot legs equal to 2. Humans have 2 legs. So I assigned value 2 here. And then human dot e dot number of eyes I need to call. So e dot number of eyes equals 2. I'm assigning some values over here also. Now to check, let's display first of all animal dot legs and animal dot e dot number of eyes. So animal dot legs and animal dot e dot number of eyes. I will just copy paste this statement because now I want to replace animal by human. Everywhere I am replacing animal by human. Basically, I'm displaying the values of legs and number of eyes for animal and human both. As per our understanding, because I'm having here human equal to animal, new is called only once. So there is only one memory. Whatever change will be done with one object, it will affect the another. So let's run this code and verify that. Copy paste, increase font size, increase font size. In this terminal, I will type the command vcs-s-verilog and shallow copy.sv. Compiling, let's simulate it. So it has printed animal.legs to animal.number of eyes to, same with human, because there was only one memory. Whatever change was made to human, it reflected to animal. Now let's try the shallow copy example. For shallow copy, I just need to make a minor change, that I need to write human equal to new animal because new is called here twice. Human is having another memory that animal, but the object anyhow is sharing the same memory. So now let's run the same code and see the results. Okay, now it made changes to human. So human dot legs are 2, human dot number of eyes are 2. But what happened to animal? Animal was having its legs equal to 4. Okay, and its number of eyes that we are expecting that it will be shared. So here I'm having animal dot legs equal to 4 because it's having different memory that human. They are not shared, but the object animal dot e dot number of eyes, it's a shared memory. That's why it's having value 2 only. They are same. Now let's look at the last example where what I want to do is I want to do human equal to new first, and then I will call the function copy human dot copy animal. Okay, now inside this living creature, let's make this function copy function void because I'm not going to return anything. So return type is void. Function void copy. Here I will pass living creature instance, say CP, and function. Inside this, I'm saying legs equal to CP dot legs and E equals CP dot E. But here I want to create a new instance because first of all I will be creating that. Now to avoid confusion, by this legs, whether it's of the same class or from the coming CP class, we use the keyword this. So whenever I say this dot legs, it refers to the legs of the same class variable. So this is used to indicate that it is of the same class. So here also I will write this dot e. I have made one function copy and I'm calling it over here. Now I'm expecting that both are having different memory. So now let's compile and run the code. Oh, there is an error of semicolon here. So now it's compile clean and run it. Okay, now as you can see, this animal.e.number of eyes changed to 0 because we assigned it no initial value. It became a default value 0, and because these two are not sharing the memory, I'm having different answer for human dot number of eyes and animal dot number of eyes. Okay, so it's clear the difference between three. Next move, let's move the next topic. Next topic is inheritance. First of all, when we heard that the word inheritance, what does it mean? We see we are inheriting some property from our parents, but from where this word came into existence into the coding. So, as per the understanding, there's a difference between class instantiation and class inheritance. Now, when it comes to instantiation, let's take this example to understand it. Suppose I have one class living creature in that I am having two variables eyes equal to 2 and nose equal to 1. Now I'm having some another class birds. Here I want to utilize the properties of this living creature class. So what I will do in this class birds, I will take its instance, say living creature L1 equals new, and I have also taken the same variable here in I nose. Next, what I will do, this dot eyes equal to L1 dot eyes and this dot nose equal to L1 dot nose. So what I can ensure from this point is that I have taken my eyes and nose from this L1. They are having now same values. Then I can have some extra variable, say wings of this class birds. So basically I have inherited properties of eye and nose from living creature. But instead of doing whole this procedure, oops provide us better way. It provides the way so that we can inherit the property directly using keyword extends. So now here what I will do, I'm having the same class living creature and I want to inherit its property into the class birds. So I will write class birds extends living creature. Now all the variables with the initial values are the part of class birds, like they are declared over here itself. Then I can add some more variable if I want, say, in wings and end class. So this is how we can understand from class instantiation we reached to class inheritance. Okay, next. So yeah, this is, I have indicated that this part of the code got converted to one keyword extends. Next task is to understand these three words, this, super, and local. I will be using these keywords later on, so let's concentrate on to learning them. First of all, this is used to access the current class properties. Okay, it is really confused sometimes, and using this keyword this is mandatory. Let's take this example. I have some class A where I'm having integer I. I'm having the constructor function of the class function new where I'm passing the variable in I. Inside this, I want to pass this local I equals the incoming I. How the confusion will be clear, because if I write like I equals I, which I refers to which one, whether the local one or the coming one. So whenever I want to refer the local I will use this keyword. Here, this ensures that it is of the class A. So this dot I equals I, which is incoming I. So like this, it is mandatory to use this keyword. The next is super. Super is used to access the parent class properties. Now I have taken another integer delay equal to 5 here, and I'm extending class B from this A only. And in that I have taken some int result and the same variable, this is int delay equals 10. Inside the function I want to do the result equal to delay of the same class plus delay of the class A. How can I access it? So what I will do is result equal to this dot delay, so it ensures that it is of class B, its value is 10, and plus super dot delay. This ensures that it is a parent class property. The parent class of B is A, and A is having here delay equals 5. So my result will be 10 plus 5 is 15. And lastly, the local keyword, that is data hiding. This extension was giving one disadvantage, that suppose I want to utilize some variable of class A which I don't want to be part of my child classes. So I can declare it with keyword local such that this class B, though it is extending class A, it won't be able to see this integer j. So this is called the data hiding using local keyword. Okay. Next is the chain constructor. Now, as we are learning class extension, what happens to this new function? So let's look at the example. Suppose I'm having class A and class, then I'm having class B extends A. Inside of its constructor function, the first statement that I will be writing is super dot new. It is called the chain constructor function, and then I will be having end function and class. So what is happening here, that whenever I will call b equal to new, then first of all it will call super dot new. Super means its parent class property. So the new function of class A will be called, and then whatever is being written into this new function, it will occur. Oops supports one level of inheritance only. So I can never call super dot new here. This concept will be clear after we look at the example of chain constructor. So let's come to the example point in chain constructor.sv. Let's take here one class A and class. Inside this, I'm taking one variable A1 equal to 1, initializing it with value 1. Then let's take its constructor function new. and function. Inside this new function, I'm overwriting variable a1 with value 2. Okay. Let's take one another class b which extends a, its end class. Here I'm taking variable b1, assigning some value say 3, and now I'm taking its constructor function new. Inside this new function, I'm calling super.new, that is chain construction. And then I'm taking b1 equal to a1. We'll see the effect of these statements while running. Let's take one module C and module. After this, I'm taking an instance of class B, say BB. Now taking one procedure, initial, begin, and first of all, I will do the calling new function to assign the memory. Now let's display the value of bp dot b1. Alright, so let's understand what I'm doing here. I'm taken one class A where I'm having a1 equal to 1, a1 equal to 2 into the new function. B is extending A, it's having variable b1 is equal to 3. In the new function, the first statement I will be writing is super.new. Then I've taken b1 equal to a1. And inside module, I have taken instance of b only, making its new, and then I'm displaying value of this b1. I want to understand like in which order the statements will be executed. So let's run this code. VCS hyphen SystemVerilog, then chain construction dot sv. It's an error on 24th line. And module. Let's compile it again. It's compiled clean and now running it. It's showing me the value equals 2. So now the order of execution here happened is whenever I am taking instance bb equal to new, the first statement that will be executed is the statement of assignment of parent class. So here the parent class of B is A. So this is the first statement to be executed. So my A1 got 1. The next statement of execution is the initial statement of self class. So it's a class B. So int B1 equal to 3, that is the second statement to be executed. Now it comes to new and it calls super.new. So the third statement that will get executed is this new function of parent class, that is a1 equal to 2. So here my a1 got overwritten by 2, and the next statement to be executed is b1 equals a1. So now my b1 also got overwritten by a1 value, which is 2. That's why whenever I'm printing bb.b1, I'm getting value equals 2 here. So it's important to understand the order of execution. This is the first statement that got executed. This is the second statement. The third statement was inside the new function. It was a super.new. So this statement is the third one. And the last statement is b1 equals a1 here. One point to make here is that even if I do comment the statement super.new and if I run the same code, let's see the result. The result is the same. Why? Because this statement is not mandatory to write. Anyways, if we call function new, the first statement by default will be the super.new of its parent class. So even if I do not call it, the compiler will automatically call the statement here. But okay, what if I am having some parameter into this new function? Say here I am having int I and I am passing say super.new than 5. I may use the I variable over here, say a1 equals I. What I've done here is, in this super.new, I'm passing some argument, and now let's see the result. So it got value 5 because a1 got 5, and here b1 equal to a1, that also got the 5 value. In this case, if I do command super.new, what will happen? Yeah, as expected, it will give me compilation error that super.new is not having arguments. Because I'm passing the argument, it is compulsory to call super.new until it won't be knowing what the value of I it should take. So the super.new is not compulsory to take, but whenever we are passing the argument, it is mandatory to write this function, this statement, and it should be the first statement only of my function new. So this is the concept of chain constructor. Let's go to the next concept. It is inheritance memory allocation, the most important slide of this presentation. The example I have taken here is, let's take some class A where I'm having int I and some function get I, its end function. I have not taken body part here because we are just understanding the memory location. I'm having another class B that extends A. I'm having the same set of variables inside class B also, say int I and function get I and function. Now, when I do b equal to new, so this b, its instance is say b only, and I have taken its new. What will happen? So let's understand the memory location part. This is my total memory, inside which here I am having class B storage allocations. So here it's a class B. So this I and get I are of class B. Okay. This is my class B storage allocation, but it doesn't stop here. It also stores its parent class allocation. So here I'm having parent class is equal to class A. So this I and get I, they are of class A. So whenever I do B equal to new, it creates memory for its own as well as for the parent class. This is the most important point to understand in inheritance. This concept will be widely used in coming slides. Yeah, what I can say that whenever I call this dot I, it refers to its old on memory, but when I call super dot I, it just points to the parent class storage allocation, and this I it returns. Now the concept is of upcasting and downcasting, which is nothing but the overridden members. So let's understand this concept. Here I have made some hierarchy here. I'm having say class A, into which I'm having some variables called int AA and int I. I'm having this hierarchy. It means class B extends class A, class C extends class A. Inside we are having some variables. C is having its own variables. This I variable is declared everywhere. This class D extends class C. This class E that extends class C, and it's having its own set of variables. Now, what I'm doing is number one, upcasting. What is the meaning of upcasting? It means casting E into A. So it means A equals I. That's what I'm doing. Now, the SystemVerilog says that this is legal by just assigning A equals E. Let's understand what does it mean. Suppose I have taken instance E1 and A1. What I'm doing is E1 equal to new. I have created object for E. As we saw in the last slide only, into memory allocation, whenever I allocate memory for E, it also stores memory locations of its parent classes. So here C as well as A. It stores all the variables of its parent classes into the memory when I do even equals new. Now what I'm doing is this A equal to E. So here what I've done, A1 equal to E1. When this statement is executed, which is called upcasting, what happens is my A1 now points to E1. So basically, into this memory allocation of E, this A1 now points to its own property. Whenever I did E1 equal to new, I was having memory of E, memory of C, and memory of A. And when I do A1 equals E1, A1 points to the part of those memory for which class A is having its own variables. So whenever I will call, say, A1 dot I and E1 dot I, what will be the difference? Say I have called E1 dot I. So it will refer to this memory location. Suppose this I is having some value, it will be passed when I call E1 dot I. But when I call A1 dot I, it refers to this memory location. Suppose here value of I is different than class E. So A1 dot I, it will reflect me this value, and E1 dot I will reflect me this I value. And both are allocated memory when I do E1 dot I. Is this clear? We'll also look at the same thing into the code example, but before that, let's just understand downcasting concept also. Downcasting, it means that I'm doing A into E. So let's say E equals A, that's what I'm doing, and SystemVerilog says it's illegal. Why? Let's understand the reason. Suppose I have taken the same thing, A1, E1. Now I have taken A1 equal to new. Whenever I do A1 equal to new, then if I do E1 equal to A1, does this instance E1 knows what's stored into this variable EE? Because what I have allocated memory for is A1 only, that is class A. So this memory is being allocated into the memory, and then if I'm doing E1 equal to A1, it is trying to refer to this location, but they are not stored into the memory, so it's illegal. So I have to do dynamic casting over here if I want to really use E1 equal to A1. So I will write the syntax $cast E1 comma A1. This will cast my A1 into E1, and then I'll be able to refer to this memory location using E1. Let's look at the example of this overridden parameters first, and next we will look at the polymorphism example. So here what I'm doing is I'm taking one class, say birds and class. Inside I'm taking some variable, say the size of bird into each equals 20. That's a default value I'm putting for any bird. Then the lifetime of bird, let's take it 10 years. Then I'm making one string for color, and the default color I'm putting brown. Lastly, I'm making one function. Its return type is void only. Say get property. And function. Here I'm making just one display statement that will display all of these three, that is size each, lifetime, and color. Let's take another example, another class. I like bird parrot, and that extends birds because it wants to use all of these properties into the parrot class. And class We know that parrot has a green color, so I would just like to override this parameter. Say string color equals green, and then I'm just copying and pasting these three lines because I want to print its property. Now I'm taking one module, let's say A, it's N module. Inside that, I'm taking instance of birds class, say B, and parrot class, say P. Next, one procedure, initial begin end. Inside procedure, first of all, I'm taking P equals new. So I'm creating the object parrot. After that, I would like to do the upcasting, which is legal only. So I can pass B equals P, as whenever I do P equal to new, it assigns memory for this birds also. So whenever I assign B equal to P, my B should point to the birds property. Let's make sure this. Now I'm calling first of all P dot get properties, and then I'm calling B dot get properties. Basically, I'm calling the function of both. As per my expectation, this P dot get properties should return me the color green. But when I call B dot get properties, because this B is pointing to the class birds, my color should be brown. So let's compile this code. We cs-s-verilog polymorphism.sv. Compile clean. Let's run it. Right. So the first display statement is 2010 green. First, I was calling p dot get property. So I got the value of size, each and lifetime from the parent class, that is 2010, and my color I got green. And in the next print statement, it is brown. So when I call b dot get property, then this b dot get property went to the birds class. It took the color brown and then printed it. So it's clear that when I do upcasting, then my P is new, so it is having memory location for parrot as well as the parent class, that is birds. Then when I do upcasting B equal to P, B refers to the memory of birds, P refers to the memory of parrot. So whenever I call P dot get property, green got printed. When I call B dot get property, brown got printed. Is this clear? So now let's move to the next part, that is upcasting with polymorphism. What is the polymorphism? This is another keyword which is most important feature of OOPS. Polymorphism means that my same code should work differently for different types. When we work for a static polymorphism, then we'll see this concept in the next tutorial, that we can access with parameterized type. And when we refer to dynamic polymorphism, it means we will be using virtual methods, say virtual function. They say that polymorphism is used for code reuse. How we are reusing the code when we call polymorphism? So let's take one example and understand the concept of polymorphism, virtual function, and code reuse. This example is most important, and pay attention to this. Okay, here this was the code I was having before. Now here I am removing this birds stuff, say b dot I'm removing, and suppose I saw one multicolor parrot. So I want to reuse the same code for working with multicolor parrot. So first of all, I will use the concept of inheritance. I will make one class m underscore parrot that refers to multicolor parrot, which extends parrot class. Right? It's a end class. Inside it, I want to override color as multi because it's multicolored. And I want these three statements over there also. So 3 y y p. Okay. Now I'm having one another class mParrot which extends parrot and it's having color equal to multi. Here everything going on is with respect to p. Whenever I started writing my code for mParrot, before that my code was with respect to parrot p. So this p, say p equal to new p dot get properties. Now in actual example there would be lots of such functions and everywhere we'll be having p dot say p dot get color, p dot get size. So in my code I'll be having lots of p dot stuff and I just want to work with multicolor parrot, so m underscore parrot. The easiest way to do it is, first of all, let's take a instant. So I will do I have taken m underscore parrot, say m. Now what I will do is, instead of changing everything in this code, I will just first of all make m equal to new because I want to work with m parrot, and then I will add one statement that is yeah, p equal to m, and I don't need to change anything into the code other stuff. What this will do, this will first of all assign the memory for mparrot, which also assigns memory for parrot, birds, that's we know as per memory location. Then I have done p equal to m. So now p, it's referring to its own properties, its own class, not of mparrot. So now if I print this p dot get properties, we know that I will get the color green. Let's just make sure it once by running it. Yeah, I'm getting the color equal to green. But now I want to work with this multi color property. So I will be using virtual function. Let's make all the function virtual. I will just write keyword virtual before the function. Everywhere before this get property function, I'm putting virtual function keyword. Now let's first see the results, what's happening into the code. It's running everything. Okay, let's make minor change that first of all I'll be assigning say b here instead of p, as we can go up to the highest hierarchy. And now let's run it. Yeah, as you can see that I was able to get multi color using just b dot get property. Now just to make sure, I will like to replace it by p again and run it. Okay, I'm getting here multi as a color. What happened? Because we said all my functions are virtual, it makes sure that whenever though I am calling p dot get property, it will call the function of highest child level. So here my highest child is m because I have taken m equal to new, which is the highest level of get property function. bird had the same, parrot had the same, m parrot had the same. So here the highest level is m parrot. And whenever I do p equal to m, though it refers to its own property, but because my function is virtual, it will display the function of the highest level of hierarchy, that is multi-parrot. And whenever I do p dot get properties, it displays the color of this mparrot class. So what advantage actually I got here? As I told you before that in my actual code, here I will be having lots of functions, say p dot some set function. I have not declared it yet, but I just want to emphasize on to the example. And then p dot some print function, etc. Now, when I came with my multi-parrot class, I took its instance. That's the first statement. I made a change. The second statement I made a change, that was here. Before it was p equal to new, I made it m equal to new. And third statement I added, it was e equal to m. I don't need to change any code beyond this line whenever it's having p. Now, because my functions are virtual, they will call the final mparrot functions only. These are the functions which will get called using p because they are virtual. So this is the example of polymorphism. Here we had the same name, get properties, but appropriate function got worked as per the virtual keyword. Okay, this is the concept of polymorphism. The last topic of today's lecture is abstract class and pure virtual function. Now, what is the meaning of abstract class? I can declare a class as virtual here. I would say that OOPS concept use virtual keyword as and when they want to use it with the property. Now, when it was used with function, you saw here, it had some different functionality. But when I use it with class, it has different meaning. It means that we can't take instance of this class, we can only extend it. So suppose in this same example, I have taken this class as, say, virtual. Now, I can't take instance of birds. So if I do this, it should give me error. Let's run this code now. So it's showing me error that I can't take instance of birds. All right. So why we use this kind of virtual classes? Sometimes in verification, you will find the necessity that you will be having some base test. It is configuring the parameters of PUT, but it is not possible to directly take instance of my base test. So to avoid any kind of confusion, I will declare it as virtual, saying the user that you can't take instance of this, you can only extend and add some of the property, then take its instance. And the last thing is pure virtual method. Now, suppose I have taken class as virtual, and inside that I am taking my virtual function, then I have to declare it with pure virtual. It means that this function is having no implementation, but in the extended class, you can have its extension. Suppose in this virtual class, I will have to declare this function as pure virtual, and it can't be having any kind of implementation. It just says that this class is having some kind of methods, get property, which you will find into the child classes. So whenever I extend this birds class, I can define this method. So in actuality, people normally put plenty of this kind of function declaration into the virtual class, just because the child class don't forget the necessity of those functions. Okay, so it's the abstract class, that is virtual class, and pure virtual methods. So inside this virtual class, we will declare pure virtual method without any implementation. That's it for the today's class. Thanks a lot. I hope it would be helpful to you. For more videos, please visit us as aspiringdirections.wordpress.com. Thank you.